We're just going to take a quick look at optimization, where you're looking to find a maximum value and a minimum value for a function on a closed and bounded interval. And I've got two examples lined up to quickly go over with you here. The first you can see is a quadratic on a fairly short interval. And let's take a look at the steps. The first would be to look for any stationary points on that interval. And in this case, well, the only stationary point is 0, which as an endpoint would have been checked anyway. So let's do that. And I will typically put a table together so I can just quickly plug and chug with those values, the endpoints and any stationary points. And here it's quickly revealed that the endpoints do give the maximum and minimum values for this section of this parabola. And that's kind of how this works. You're looking at a section of a curve, and assuming that it's well behaved enough, you'll achieve maximum value and minimum value. So let's now take a look at a trigonometric function. Well, not exactly completely trigonometric, and that's revealed in our stationary point analysis. Good thing that x term was there. We now have a 1 along with our cosine function, and we're able to find 7 stationary points where the cosine is 1/2. And I hope the unit circle might help you make sure of that. And that gives us a much lengthier table this time with 7 stationary points and 2 endpoints, but it's not that bad to work out what the results are for each of those inputs, and then the outputs reveal themselves pretty clearly to you by ranking. You can just immediately see which will be largest and smallest, and in this case it jumps out on the graph that our maximum and minimum values are at -3 pi and positive 11 pi over 3 respectively. What's the summary? Well, as we've seen, stationary points, if any, evaluation, and then read it off. Thanks so much.